All right, example 3, we're doing determining whether things are functions or not. We got several different types of relations going on here. We have a set of ordered pairs, we have a couple equations, we have a mapping. And to determine if a relation is a function for a set of ordered pairs, first off, the first thing I do is I look at all my x's. So my first number in each ordered pair represents x. If they're all different, the answer is yes. Okay. As you can see, the ones I've got highlighted there, 2, 4, and 4, 4's are the same, so we can't immediately say yes on this one. The next thing we look at, if we don't get the immediate yes because they're all different, is we look at the y values on the same ones. All right, so 4 and 4 are the same, so I look at the y values of 1 and 5. If the y values are also the same, it's still a yes. If the y values are different, it's a no. The reason being that 4 goes to 2 different numbers. So on a no answer for a function question, I want to know why. And when you're dealing with set of ordered pairs, that'll be the reason every time if it's a no. This specific x value goes to 2 different y values. That makes it a no. If it was 2, 3, 4, 1, and 4, 1, that'd be a yes because 4 is going to 1. Happened twice, but it's still the same point. It's still a yes. But as soon as a single x value goes to 2 different y values, then it's immediately a no. For an equation, 3x plus y equals 1, negative 4x squared plus y squared equals 9. One of those is a yes and the other one's a no. Which one, just if we had to guess, which one do you think is a yes? B or C?
C.
I got some B's, I got a C.
I just said that.
Right. You just want to be different?
Because C is squared.
Alright, you think C squared, that means it can't be, and then B isn't, so that means yes? Is that what you're thinking? Is that your theory?
Yeah, because a number has a bunch of squares.
Here's how you figure it out. Keeping in mind that if this type of thing happens, it's a no, right? Mm-hmm. Alright, think about the types of ordered pairs you get on these functions. 3x plus y equals 1 is a linear function. It makes a line, right? And since both x and y are there, it actually makes a slanted line. So if I was to graph that thing, the graph actually looks like this. This is the x-axis, that's the y-axis, that's the graph. It would actually be about, it actually be kind of about here. Doesn't matter what it looks like, but it would look kind of like that. Okay? Imagine trying to make a set of ordered pairs to this. This would be y equals negative 3x plus 1, right? Mm-hmm. If I made a set of ordered pairs here, x, y, you don't have to do a set of ordered pairs, you just have to get to the point where you're convinced that it is or isn't. If I pick some x's, let's say 0, 1, 2, 3. Let's say we pick those x's. All right? 0 times negative 3 plus 1 is 1. 1 times negative 3 plus 1 is negative 2. 2 times negative 3 plus 1 is negative 5. 3 times negative 3 plus 1 is negative 8. All right, consider evaluating each of those. Is there some time when I'm going to put a number in like 4 and get 2 results out? Is there some number out there that I'm going to multiply by negative 3, then I'm going to add 1, and I'm going to end up getting 2 different answers? Because that's what happened here. They put in 4, got 1, they put in 4, got 5. They put in 4 and got 1 and 5, 2 different answers. If I put numbers into this expression here, is there any way to multiply a number by 3, a negative 3, then add 1 and get more than one answer? No, there's not. There's only one answer available, right? Y equals whatever that equals. Negative 3 times x plus 1 creates a single answer for every x. You put 1 in, you get 1 out, 1 in, 1 out, 1 in, 1 out. That's what a yes looks like. So part B is a yes. Now, if we use this ordered pair idea for C, we do C in red over here in the space. Let's say I made a little XY chart here. Gracie, pick an x value for me. It doesn't matter what you pick. 2. All right, Gracie wanted to pick 2 for x. All right, so if I go over here and change x to 2, let's watch and see what happens. I'm going to get negative 4 times 4, right? Because 2 squared is 4, right? Mm-hmm. Plus y squared equals 9, which that's negative 16, right? Mm-hmm. So if we move it over here, it comes plus 16. I guess we get y squared equals 25. Wow, squared is really bad. Okay, y squared equals 25. So what does y equal?
5.
Anything else?
Plus or minus
Plus
5.
or minus 5, right? 5 times 5 is 25, negative 5 times negative 5 is 25. So Gracie picked a number randomly. I didn't set Gracie up beforehand. Hey Gracie, pick 2 when I call on you. I didn't do that. She just picked 2 because she felt like it. All right? We put 2 in and we got positive 5 out. We also got 2 negative 5 out. We put a single number in for x and we got 2 different values for y. Same thing that happened here, right?
No.
That's going to be a no.
Gives us multiple numbers.
Okay, as a general rule, okay, and this is, I don't think this is 100% foolproof because I haven't actually gone through the proof involved with it, but for me personally, if I'm looking at a function, if y is to an odd power, it's usually yes. If y is to an even power, it's usually no. Usually. Alright? Doesn't matter about x, it matters about y. If y is to an odd power, yes. Even power, no. Because odd powers, when you take a cube root, you get a single answer. You take a 5th root, you get a single answer. 7th root, single answer. Square root, plus or minus. 4th root, plus or minus. 6th root, plus or minus. Every one of those even powers, you're going to get that plus or minus, creating multiple answers for specific numbers. So usually even power, no. Odd power, yes. And as far as writing the answer to this, we're going to say no because 2 goes to 2 numbers. Goes to 2 different numbers. Pretend I circled the no. Didn't make it better, did it? There. Alright, finally, the correspondence between the x values and the y values of the following figure. Alright, this is a mapping. It's a way of doing ordered pairs that doesn't show up as ordered pairs. Instead of x, y ordered pairs, this x goes without y. So x1, y1 is an ordered pair for this. x2, comma y2, x3, comma y1, x4, comma y4, x5, comma y3. Again, considering what function means, every x must go to exactly 1 y. That's the rule, okay? How many y's is this x going to?
1,
1. How about this one?
1, 1.
And that one?
1,
And this one?
1.
And that one. All right. Even though these 2 are going to the same one, it doesn't matter. They're only going to 1. That's the rule. Okay, so this is a yes. What would make it look like a no, in case you're interested? This would make it a no. Now x2 is going to 2 things. I'd say no because x2 is going to 2 things. I mean, as far as the reason, that's the reason. It's just an x value goes to more than 1 y value. That is what makes it not a function every time. Again, the original problem didn't have that blue line, so I took it off. So this is a yes because every x, even though again these 2 are going to the same one, this goes to 1, this goes to 1, this goes to 1, this goes to 1, this goes to 1. That's what yes looks like. That's what we're going to do.